Welcome to how to identify electrolytes. So we have electrolytes and non-electrolytes. Electrolytes are substances that are going to dissociate into ions when dissolved in water. So the key here is understand that we're talking about ions. So an example of this is salt in water. So a salt in water would be something like sodium chloride. Sodium chloride is going to break up into sodium ions and chloride anions. Non-electrolytes may dissolve in water, but they don't dissociate into ions when it does so. One way to think about this is if we were to take pure water does not conduct electricity. And so we can see that we have these two electrodes leading to the light bulb. And so if the current is passed from this electrode to the other electrode, the light should turn on. But in pure water, that doesn't happen. Why is that? Well, the reason is there's no ions to transfer that current. In a sucrose solution where we have some kind of sugar dissolved in water, what happens is, again, that current can't be transferred from one electrode to the other, and so the light bulb doesn't turn on. However, if we take sodium chloride, which we know is sodium chloride, we have sodium ions and chloride ions. Those are going to form ions, which then can transfer the current from one electrode to the other, leading to the light bulb being turned on. So when we think about an ionic compound, the reason that it can conduct electricity is because an ionic compound breaks up into its component ions. So here, sodium chloride is going to break up into sodium ions and chloride anions. As water interacts with the sodium or the chloride ions, water has a partial negative charge on the oxygen and a partial positive charge on each hydrogen, which means that the negative charge or the partial negative charge of the oxygen is going to surround the positive charge of the sodium ion. And you can see where each of these oxygens is kind of lining up towards that sodium ion. On the other hand, we have chloride anions, where the hydrogens, which are now partially positive on water, are now going to interact with the chloride anion. And so it pulls this ionic compound apart, where each ion is surrounded by water molecules. These can then conduct electricity. For a molecular compound, which is primarily composed of only nonmetals, we can see something like methanol, which is CH4. What happens is this can't break up into component ions. It is a molecular compound. It doesn't make ions. And so the water molecules may still surround it, and they may help to dissolve it, but they're not going to conduct electricity. Therefore, they're not an electrolyte. So again, we talk about electrolytes. They are substances that dissociate into ions when they're dissolved in water. We call that ionization. There's two classes. There's strong electrolytes and weak electrolytes. A strong electrolyte ionizes completely, meaning that 100% of all of that compound is going to ionize into its component ions. These include things like ionic compounds, strong acids, and strong bases. Weak electrolytes ionize only partially, maybe only 1 to 10% of all the molecules actually ionize. These are weak acids and weak bases. So one of the things you should be able to do is classify a strong versus a weak electrolyte. Really, if we just remember this table and understanding that when we think of the two classes of compounds, we either have ionic compounds or we have molecular compounds. Ionic compounds, all ionic compounds are strong electrolytes. Whereas molecular compounds can be broken up into strong acids, which under this we could also write strong bases in this as well. So whenever we talk about the strong electrolytes, these are going to be strong acids and strong bases. The molecular compounds that are weak electrolytes would be weak acids and weak bases. All other compounds are going to be non-electrolytes. So anything besides an ionic compound, a strong acid or strong base, a weak acid or a weak base, everything else falls into this category, which is a non-electrolyte. That completes how to identify electrolytes.